What's up, everybody? Hutch here, and this is your Module 13-4, all about dilations. Be aware, it's not called dilations, just dilations. Maybe you've heard of getting your eyes dilated at an eye doctor, where your pupils get really big. If you've experienced that, it's really wild. It makes you seem super old because you can't see up close until the dilation calms down. So dilation is just a shrinking or enlarging of a shape. So let's make that note right here. So dilations shrink the shape or enlarge. Okay, N meaning making large. All right, so let's go ahead and take a look at our Math Shorts video by clicking the image below, and we'll fill in these blanks. Let's take a look. It says dilations is the process of making the object blanker or blanker without changing its shape. So we talked about shrink or enlarge. What would that mean? Making the object larger. So let's fill this in. Or smaller without changing its shape at all. So the shape doesn't change, but you have to understand now the side lengths are larger or smaller. And that's why we say that it's similar, okay, but not congruent, okay? So that's something to be aware of with that, okay? All right. Let's go ahead and take a look at the next one. It says dilations of a shape grows or shrinks blank from a point called the blankety blank blank blank. Let's wait on that one. A blank blank determines how a shape grows or shrinks. You know this, but let's wait for the video. Blank sizes, blank proportions with dilations. We'll wait on that one as well. Let's head to a video and try to fill in some of these spots. So here is your Math Shorts.
Math Shorts.
Understanding dilations. In math, dilation refers to the process of making a polygon larger or smaller without changing its shape. It's picture day.
We got that, larger or
Kate
smaller.
chooses the package with one photo for her parents, a larger one for her grandparents, and smaller photos for her friends. How can photographers print one photo in different sizes? Dilations. Dilation is where a two-dimensional shape grows or shrinks proportionally from a point called the center of dilation.
So you can see the angles
Here
aren't
we
changing,
tripled
but the
the
side
original
lengths are.
rectangle. And here we divided it in half. In dilations, the dimensions and distances from the center of dilation stay in proportion. The center of dilation can be anywhere in, on, or outside of the shape. Scale factor determines how a shape grows or shrinks. If the scale factor is 3, the dimensions from the center of dilation are multiplied by 3.
And we know about scale factor.
Different sizes, same proportions, same shape. A coordinate grid can help us see how this works. If the center of dilation is 0, 0, and the scale factor is 3, the horizontal distance from the center of dilation is 3, and the vertical distance is 4. Multiplied by a scale factor of 3, the horizontal difference becomes 9, and the vertical distance becomes 12, stretching the shape 9 units to the right of the center of dilation and 12 units up. Nice portrait, Kate. Grandma and Grandpa are so proud. If the scale factor is 1/2, the original dimensions are multiplied by 1/2. The dimensions of the reduced photo are 1.5 and 2. Different sizes, same proportions, with dilations.
All right, so let's go and fill out some more of these. So it says dilations of a shape grows or shrinks, and we have the word proportionally. You're gonna have to squeeze this in smaller. Proportionally from a point called the center of, and remember that's spelled D-I-L-A-T-I-O-N, not dilation, okay? All right, what determines the amount that something grows or shrinks? We'll put in parentheses here the multiplier. What do we call the multiplier? That is our scale factor. And we know all about that, okay? All right, so the big thing with these ones are we don't have same sizes. We have different sizes, okay? But the proportions are the same, okay? So same proportions with dilations. All right, so how to find the scale factor. This is something you're familiar with. We're actually going to do it different right here. So we have our pre-image, okay? And we're wondering, what do we multiply by, okay, to get the image then, okay? Or our P prime, okay? And so, of course, to figure this out, if we are going to solve for x, so let's pretend that our scale factor was s or x, whatever that is. Obviously, to get x by itself, we would divide by p, okay? And divide by p, this would go away, and we would have x equaling what our scale factor is, okay? So just being aware of what we're doing there, okay? So that's how that works here. This little spot here is our scale factor, okay, this SF. Okay, so pre-image times what gets you your new image, and we know that we can also just do, okay, so we could say or P prime divided by P, and that will equal our scale factor. Okay, so this is how we can solve for scale factor, is think about this or think about that. Okay, all right, so let's go ahead and take a look at this one here. Okay, so always focus on where we're starting. Okay, and we can just look at one of these side lengths, so, but we need to use it the same, look at the same like sort of corresponding side on the new image. Okay, and so remember, we're asking ourselves to go from pre to image. 8 times what equals the 6, okay? Or we know we could just do 6 divided by 8 to get our scale factor. So what is our scale factor? Well, we would just grab our calculator, do 6 divided by 8, and it'll tell us what our scale factor is, okay? Or you could just use 6 divided by 8, but let's go ahead and see our scale factor is 0.75. So 0.75 equals our scale factor. Okay, so that is also, remember, our multiplier. Okay, so going back to something very familiar, we had to figure out multipliers before with this kind of stuff, so this part isn't new for us. Okay, and does that make sense that the multiplier is 0.75? Well, yeah, because our shape decreased in size. Okay, all right, let's go ahead and figure out the scale factor here. I noticed the prime, so I'm going from the 2 to the 4, okay? We could look at the 2 to the 4. We could also look at the 1 to the 2, okay? However you want to do it is fine. It doesn't matter, okay? So option 1 is 2 times what, okay, equals 4, okay? Or we can say 4 divided by 2 equals scale factor, or x, okay? So what is the scale factor? Well, 4 divided by 2 is 2. Okay, so 2 equals the scale factor, okay? And that means we would take our number 2 here, multiply by 2, and it would equal 4, and that would work for all of our side lengths, okay? All right, let's go ahead and take a look down here at some key concepts, okay? As we get to this spot here, a couple things I want you to pay attention to is this is an enlargement, okay? We're going from a pre-image to a larger new image, okay? And what I want you to be aware of is how we would identify the scale factor. So it's obviously getting bigger. If it's getting bigger, we know the scale factor is larger than 1, right? Okay, and so all we have to do is identify a side length. Now remember, can you count diagonal side lengths? No, you cannot, but you can count straight ones. So this side is 3, and 1, 2, 3, 4, 5, 6. This side is 6. So we're going from pre to image, so from 3 to 6, okay? And you can just sort of think, okay, well, from 3 to 6, 3 times what equals 6, so the multiplier is 2, okay? So our scale factor equals 2, and you can see to represent that in mapping, we just show that we have 2 times x and 2 times y, okay? So that's how we do the mapping. Now to do a reduction, okay, because our original is shrinking, obviously the scale factor has to be less than 1, right? Okay, so again, we would just look at a side length. Okay, all I have to do is pick one. It doesn't matter. So I'm just going to pick the 2 here and the 1 here. Okay, so I'm going from, and this is what you have to pay attention to, I'm going from 2 to 1. And that's why I like showing the little arrow here like this. Okay, so if I'm going to 2 to 1, what am I doing? Well, 2 times what equals 1? 2 times a half. So the scale factor equals 1/2, or you could say 0.5 or whatever. Okay, and so you can see to represent that in the mapping, okay, all of my x's I would multiply by 1/2, and all my y's I would multiply by 1/2, and it will create my new shape that is half the size. Okay, be aware also all these centers of dilation are from the origin. Okay, and so we talked about in the video how there were different ways that you could dilate. And so you just have to pay attention to that kind of thing as well. All right, no change at all. You can see the pre-image and the regular new image is over top of each other. So obviously this is a scale factor of 1. And we represent it right here, 1x and 1y. So there's no change. Okay. All right, let's go ahead and slide down to this next page. And we're going to go ahead and take a look at what it's asking us to do. So triangle ABC has these vertices. Graph the image after a dilation with a, let's highlight this, scale factor of 2. Okay, so let's start off with triangle ABC. We're going to start off with blue, I guess, for our image. So -2, 1, 1, 2, 1. Okay, and so here's point A. Then we have -4, 5, 1, 2, 3, 4, up 5, 1, 2, 3, 4, 5. There's point B. And then we have C is 3, 2, 1, 2, 3, 1, 2. Okay. And I'm going to go ahead and connect these points to create the triangle. Oh, I'm going to have to free draw that one. It's not locking in nicely for me. There we go. Okay. So there's my triangle, okay, and we need to now do a dilation with a scale factor of 2, okay? And so what we're going to do is we're going to take these points, okay, and since we have a scale factor of 2, we're going to map out what we need to be doing. So let's set up our mapping, okay? Remember, our mapping is our rule, okay? And our mapping says that we should take our original xy, and when we do the transformation or this dilation, okay, we're going to double the x and double the y. Okay, so we have that like coefficient. Okay, so now all we have to do, I'm going to switch to red now, and we're going to go ahead and lay this out. So my original A was -2, 1. So what would my A prime be? My A prime would be double that. Okay, so -2 times 2 is -4. So you got to do your integer rules here. -1 times 2 is 2. Okay, what would B prime be? Well, -4 times 2 is -8. And 5 times 2 is 10. And then C prime, we're looking here. 3 times 2 is 6. 2 times 2 is 4. Okay, and now all we have to do is plot those points, and we'll have the enlargement dilation. So -4, 2, 1, 2, 3, 4, up 2. Here's our new A prime. -8, 10, 1, 2, 3, 4, 5, 6, 7, 8, and up 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All the way up here is B prime. And then C prime is 6, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. Okay, and there's C prime. Let's go ahead and connect our dots. I'm going to lock this in the best I can. Lock in this one. There we go. Straight line. Lock in this one. Best we can. I think, yeah, that's probably the best I can right there. Okay. All right. So you can see our dilation. Okay. And this is an enlargement dilation. Okay. And that's how you would do that. So let's head over here and you can try this one on your own. We have triangle JKL has these vertices, and they want you to show a dilation with a scale factor of 1/2. Okay, so let's go ahead and you can pause if you want or follow along. I'm going to go to blue again. Let's create our mapping real quick. And our mapping starts at XY. And what does it do? Well, it's a 1/2 dilation. Okay, so 1/2 X, 1/2 Y. Okay, or 0.5, however you want to write it. So let's go ahead and do our pre-image. So we have J is 3, 8, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So here's J. Let's do 10, 6 for K. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. 10, 6 is K. And then we have L is 8, 2. So 10, 9, 8. So 8, 1, 2. There we go. And that's our L. I can go ahead and create my triangle here. Lock in this stuff. Straight line, there we go. All right, so there's triangle JKL. We're gonna go ahead and graph the image after a dilation of 1/2. Okay, so I'm gonna switch to red now. Okay, we have J prime. Okay, it was 3, 8. So this is going to be a little bit different. So half of 3 is 1.5. Okay, and that's okay. We're following the rule. Half of 8 is 4. Okay, we have K prime. Half of K is 5. Half of 6 is 3. Not half a K, half a 10. And then we have L prime was 8, 2. So half of that would be 4, 1. Okay, now we can go ahead and graph that. So 1.54, you just go over 1.5 and up 4. 1, 2, 3, 4. So here's J. We have 5, 3. 1, 2, 3, 4, 5. 1, 2, 3. And that's K prime. Sorry, I missed my prime there. And 4, 1. 1, 2, 3, 4. Up 1. This is our L prime. Go ahead and connect our points. And there we go. Okay, and you can see when we talk about dilation from the origin, okay, you can see this distance, okay, from the origin itself, okay. So as we shrink, it's shrinking toward the origin, okay. So something to be aware of when we talk about those different points of dilation, okay. All right, scroll down to here. Let me sneeze. Oh, sorry. Bless me. All right. Excuse me. Sorry about that. See, you're safe because you're watching this from afar. So you're not even getting sneezed on. Lucky you. All right. Use the coordinate notation to describe the dilation now. So we're just going to create some mapping, identify what the scale factor is. This one will be pretty quick here. I want you to just pick a point that you want to use. Okay. I would pick a point that you can clearly see is either on the inside and then going to the outside. It has to be the same point. So you have to compare C to C or A to A or B to B. Okay, you can't flip-flop those. Okay, identify where the pre and the new image is. Okay, so it's always nice to draw that arrow of what you're doing. So we're shrinking. So we already know the scale factor is going to be smaller. Okay, and as we do this then, okay, what I want you to do is just identify the ordered pairs for both of these C's, okay? So let's go ahead and look at the pre-image. So I'm going to do this in blue. So the pre-image C is ordered pair 1, 2, 3, 4, and 1, 2, 3, 4. So 4, negative 4, negative 4, okay? And then we go to C prime. And what's that? It's negative 2, negative 2. Okay? So then you just ask yourself, well, what happened from X to Y? Okay? And so on the side, remember scale factor, we're saying, well, from negative 4, what is my multiplier? Okay? So times what got me to negative 2? Okay? And so you just sort of think, well, I'm cutting that in half. Okay? Or if you're not sure, you can always do the negative 2 divided by the negative 4, and you can see we have a scale factor of 0.5. Okay, so that identified my scale factor equals 0.5 or just 1/2. Okay, so let's go ahead and write our official mapping. So our mapping is we take x and y, and over here we take 1/2 x and 1/2 y, and that'll create our shrunken new image. Okay, so that's all I want you to do for this. So let's try it on this one. Be aware of where the pre-image is. Okay, so let's go with C again, so we're doing the same one. Okay, and actually let's stick with the positive side. We might as well stick with our A's because they're both in the positive, just makes it nice. So we're starting here and we're going to here. So again, that's my tip to you, is identify where your pre-image and where your new image is. All right, go ahead and write your ordered pairs and then create your mapping once you identify the scale factor, okay? Because it does say state the scale factor and use coordinate notation, which we know is also called mapping, okay? All right, so pause if you want, or you can follow along. Here we go, okay? Pre-image is over 1 up 2, so 1, 2. Changes to A prime, which is over 1, 2, 3, and up 1, 2, 3, 4, 5, 6. So it goes to 3, 6. Okay, so then you just ask yourself what happened for scale factor. Okay, so I went from, if I just pick x to x here, I went from 1 times what got me 3. Okay, and so 3 divided by 1, obviously 1 times 3 is 3, so my scale factor equals 3, okay? All right, so now that we know scale factor is 3, we can create our mapping, and our mapping is just x, y. What do you do to the x and the y? Well, I multiply times 3 for the x, and I multiply times 3 for the y. So 3x and 3y will create my enlarged image, and there we go. Okay. All right, here's your apply problem, and that's it for today. Here's plans for a new fence that Olivia is building on her horse farm. Each unit on the graph represents 8 feet of fencing, so be aware of that. Okay, it does have like a little key there. After studying the plans, Olivia decides she would like to build a fence that encloses a greater area. Okay, she's going to dilate the rectangle. So here's some information. We're dilating the rectangle, scale factor of 2. Okay, and the fencing costs $12.50 per foot. How much will she spend? Okay, all right. So first thing is, I know every square is 8 feet. So that's something to just be aware of that we need to remember. Okay, as we're coming up with our total amount of feet. Okay, so let's go ahead and first enlarge this by a scale factor of 2. Okay, so if we look at our original distances here, okay, I have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. Okay, so we have the 6 by 4. We're going to enlarge it. Okay, for this one though, there's a couple ways, remember, to enlarge or dilate something. You could dilate from a point. So if I dilated from point D, okay, I would just enlarge this length and this height, and it's going to expand it out from D. Okay, if I want to expand out from this origin, okay, I'm going to pick a ordered pair and go ahead and dilate all the ordered pairs. And if I dilate every ordered pair by the scale factor, it's going to send things out like this from the origin. Okay, so just a couple things just to be aware of that if you're how you're going to enlarge or dilate the shape. Okay, so let's go ahead and for this one we're going to dilate from the center. Okay, so if we're dilating from the center, a couple ways to do this. Okay, I can also look at how far we are from the center and how far we are from the center and dilate that way. Okay, or we can go ahead and dilate from the ordered pair itself. Okay, so let's go ahead and take a look at this. I'm 2 away here, I'm 3 away here. So if I dilate from the center, okay, and we do a scale factor of 2, instead I want to move 4 out, right? Okay, so 1, 2, 3, 4, So I'm going to go all the way out to here, and the 3 is going to turn into 3, 4, 5, 6, and go all the way out to here. And we're going to do the same thing below and to the left. Okay, so we'll go 4 down, 1, 2, 3, 4, and we're going to go 6 out to the left, 4, 5, 6, and go here. Okay, and so now I have this larger image. Okay, we can sort of connect and create the same distance going all the way around, lock all of this in, and I've dilated from the center. Okay, so that's one way to think about that dilation. Okay, I'm going to go ahead and make my labels here. So we have A prime, B prime, C prime, and D prime. Okay, all right, now let's go ahead and we're going to look at your distances now. Okay, and so as we look at the distances of things, remember that each box is actually 8 feet of fencing. Okay, so one of the things that I would like to do is go ahead and actually calculate how many feet we actually have with our new fencing. Okay, and so let's count all of our spaces. Okay, this whole distance. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we have 12 feet this way. Okay, but it's not really 12 feet, remember? Okay, it's just 12 spaces, and each space is 8 feet. So remember, each square equals 8 feet. So really, I have 12 times 8, okay? And if you're not sure, yeah, just do it like that. And you can see 12 times 8 is 96 feet, okay, across. And then what are we at now? So we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, and so we have 8 times 8 is actually 64 feet, right? And if you're not sure, you double check on your calculator. Okay, so now we have our actual dimensions of the new garden size, and we converted it to the proper amount of feet. Okay, so let's go ahead and take a look here. It says, after studying the plans, Olivia decided she would like to build a fence. And so the fencing is $12.50 per foot. Okay, so let's go ahead and calculate that perimeter. We know the perimeter formula. Okay, perimeter equals 2 of the length, okay, and 2 of the width, right? Or 2 times length plus width, either or, okay? So 2 of the length, okay, our length is 96. So 2 times 96 plus 2 times 64, and what do we get for an overall perimeter? Let's go ahead and type that in. So 96, 2 times 96, oops, 96, 96 is 192. Plus 2 times 64 is 128. So the overall perimeter in feet, 192 plus 128, is 320 feet around. Okay? All right, now that we know that that's the amount of feet around, okay, let's go ahead and calculate the cost, right? So the cost is $12.50 per foot, so times 320. And so let's go ahead and label this cost. So our overall total cost equals 320 times 1250, a whole bunch of money. Total cost is $4,000. Okay. All right. So that's how you would do something like that. Okay. All right. That's it for today. Let me know if you have any questions.